Mars. We're sending some more satellites to monitor Mars. We have a bunch there already. This one's called ESCAPADE, and it's talking about the solar wind and its effect on Mars. That's of a lot of interest because in the past, people thought that, well, Mars doesn't have much of an inherent or intrinsic magnetic field, unlike Earth, where because of the molten core with the iron and everything, we get a magnetic field. They don't have that. There is a magnetic field there. It's mostly induced by the solar wind itself. What they're really trying to find out, how the magnetosphere guides the flows of ions and how that affects what's coming in and out of the atmosphere. It's been a theory that one reason we don't have an atmosphere on Mars is that the solar wind just blows it away because the solar wind is not stopped because there's no intrinsic magnetic field in Mars, almost none to speak of. That was widely believed as the cause. And actually, from the more recent observations, including another satellite up there called MAVEN, they've concluded that actually it's a factor, but it's not the only one. Actually, just gravity itself is a big factor. Gravity tends to hold in the atmosphere, which isn't surprising either. So what they want to do is just get a better handle on the atmosphere. How is it lost? Because after all, if you're going to terraform Mars at some point, you don't want the atmosphere just to blow away. There's no point in doing it if there's no chance of keeping it. And actually what they're thinking right now is, well, if you could do it, it probably would stay for quite a while. Anyway, besides affecting the atmosphere, it also affects the ionosphere, which affects radio communications. Anyway, that's coming up soon. That one has not been launched yet. That's going up on the second New Glenn rocket, which is coming up at the end of this month. It really is 2 satellites, not just one. They are pretty small compared to a lot of the old big geostationary satellites we used to send up. They weigh, without propellant, about 440 pounds each. They weigh 1,200 pounds at propellants. Anyway, the instruments they have, they measure magnetism, static electricity, basically ions and electrons, plasma density, and ultraviolet, because they say extreme ultraviolet in particular is another reason where probably that causes a lot of chemical reactions, for instance, breaking up CO2 or O2 molecules, and then they end up going off into space. And it's actually built by Rocket Lab. They have what's called the bus, which is sort of the core of the satellite. The key thing about this is it's a low-cost mission, and there's a whole program they had at NASA called Simplex, very much like the commercial lunar landing program and some of the others, the commercial crew, where they tried to figure out ways to do everything a whole lot cheaper, and this was one for small missions. Originally, it was just going to be a secondary payload on a different mission. In this case, it was the mission to Psyche, which is the metallic asteroid that they're sending a prospector to. But the timing didn't work out on that. They weren't ready when Psyche was, and they also changed the rocket, and they just didn't have time to react to it. So then they were going to go on the first New Glenn launch. So that is the rocket for Blue Origin. And they were going to pay $20 million for that. So essentially it was free. They had a free ride before, and now they were paying $20 million. But then New Glenn wasn't really quite ready, and I think, again, they probably weren't ready either. So they put that together. It was just too risky. Finally, they ended up being the second New Glenn rocket. The total cost of this is still about $80 million. And it's been in a relatively short amount of time, a couple of years. It may sound like a lot to any of us personally, but actually for rocket launches, for a whole spacecraft going to Mars, this is a whole lot cheaper. It's not the cheapest ever. Actually, the Indians did that better. They sent an orbiter to Mars, and they did it for about $73 million. So actually, they are still the record holders for putting up the cheapest satellite around Mars. And by the way, each one of those still costs less than making the movie Gravity. So a trip to Mars, suppose you're NASA, and imagine you're a NASA administrator or something, and back around December or so of 2024, there was a launch window to go to Mars. And by launch window, I mean a Hohmann transfer orbit, which is a standard thing, which is shown on the right-hand side here, where you can see there's the sun in the center of that, you got the Earth orbit there in green, and you got the Mars orbit in red. And you get up into low Earth orbit, or at least an orbit around Earth, and then you do what would be called a trans-Mars injection, where you spend some propellant and you send it off, and that gets you out ultimately to the orbit of Mars. So you do it in 2 burns. One is get into an elliptical orbit heading toward Mars orbit. That's an ellipse. And then what you do is you fire, when you hit the Mars orbit area, you fire again. So it's 2 blasts of propellant and you match Mars orbit. It's an optimum under certain assumptions. Like all of these things on this picture are in one plane. There's only just 2 instantaneous bursts of fuel and no other gravitational influences. You're not getting gravity assist. Anyway, but it wasn't available in time. The next launch window is now in December 2026. That's the next time you really can go to Mars cheaply. You missed the previous one, you'll have your rocket, the New Glenn 2, is ready in October. And even that, you can't really be sure it's going to be ready. They're not always on time either. Anyway, what do? Do you just wait? And the answer came back as no. They do something completely different. And this had not been tried before. So they're launching toward the Earth-Sun L2 Lagrange point. That's the one on the other side of the Earth. And what they're going to do is basically, in a way, they're just storing it. I mean, essentially, they're going to put it in orbit around that L2 point for like a year, close to it anyway. And then pretty much at the end of that, they dive toward Earth, they get a gravity assist, and then that shoots them up. Kind of hard to see on these thin lines. You start off, Earth is there in the center of this picture. You go up in this long kidney bean shape up and come down and around to the right. And you come back up, then you dive toward the Earth, and then right back in the center there, it looks like a very sharp orbit. That's when you do your final blast to head towards Mars. And then you're on a normal Hohmann transfer. So it's a roundabout way of doing it, but it works. And it gets you out there earlier.
Really?
Well, okay, no, it doesn't get you to Mars any earlier, but it gets you out into space earlier. So there's two advantages of that. One is at least you're up there and you're insulated from things like government shutdowns and that kind of thing. The second thing is you have much more flexibility in your launch timing. Because you're basically just wasting time out there, and you can pick the orbit to waste just the amount of time you want to come back with a lot of flexibility. And they figured anywhere from October to March of next year, they could launch this thing, and it'll still work out. And of course, the other thing is, it's just being stored out there in space, but on the other hand, it's doing all that same kind of monitoring that we want to do anyway. I mean, it's monitoring everything with the solar winds, the ions, the magnetic fields, and so on. So it's getting good science done in the process. And they figured, well, that's better than just having it sit on the ground. It's not the only satellite there. There's actually 7 others that are active right now. 3 of them are already there from NASA, Odyssey. Most of them are pretty old. The Mars Reconnaissance Orbiter in particular is one of the best ones, though, and it's been used as a relay satellite. It's used for pictures, and it's been mapping Mars, doing all kinds of things. MAVEN was kind of specialized in some of this upper atmosphere stuff also, but even that's from 2013. The European Space Agency has a couple satellites up there. One of them was a joint project with Russia. One of them was their own. The UAE, they have one. They put one up there in 2020. They didn't provide the rocket, but it is their spacecraft. China, used their own spacecraft. They put up an orbiter in 2020 also. So there's all kinds of satellites up there already, not to mention another 10 that have already been there, done their thing, and died for one reason or another. In particular, the one that's shown on the right there is the one from India. It finally got caught where it went without sun too long during an eclipse, and it just died, which is always a risk, when you're orbiting planets. Okay. Other space-related videos or slide presentations by me are available at the link shown here. That includes a list of videos at my YouTube channel, so you can view them or subscribe for notifications about future videos. These presentations are mostly made as part of the meetings of National Space Society's North Houston chapter, and the link to that is shown. Topics like these are presented as part of a monthly news segment, and there are also lots of other interesting speakers and open discussions. You can attend in person or online via Zoom. Come join us.